Hello everyone. So today I'm going to discuss the topic of PD formation. Every year you will find a 10 mark question from this topic in mathematics optional paper 2 in section B, because PD is part of section B. So every year compulsory 10 mark question comes from this topic. So that is the reason you should be well versed this topic. You should practice enough. So there are two kinds of questions that are usually asked from this topic. Okay. The first is the kind of question which is elimination of arbitrary functions. And the second is elimination of arbitrary constants. Okay. So without any delay, let's start. Okay. So what is formation of PDE? That you will be given a equation. Okay. So if I'm given equation, given equation in, let's say, f of xyz is equal to some constant c, you convert it to a function, let's say capital F of x, y, z, p, q, or r, s, t. All these are symbols for differentials, devoid of arbitrary functions or constants. Okay, so this is the way. So for example, let's say if I give you a equation, very simple equation, let's say I give you a equation of a plane. Okay, equation of a plane where z equals to ax plus by plus a square plus b square. Now I have to find the PDE for this. So I differentiated with respect to x. So del z by del x, which is called P, is equals to a, because y will become 0 and this is constant, will become 0. Similarly, del z by del y, which is q, is equals to b. So from this we know that p is equals to a and q is equals to b. The equation can be written as z is equals to px plus qy plus p square plus q square. So this is the PDE for the given equation. So this was a very easy question. Okay, and this method is called elimination of arbitrary constants. Okay, what is the arbitrary constant? Arbitrary constant means a constant whose value we can change. Okay, here ax, by, if you keep changing the value of a and b, you will get different planes, different equations of planes. Okay, so where p is del x by del z by del x, and q is del z by del y. So let's see first notations. Okay, what are the notations? Then we will move forward on the methods. So what are the notations? So p means del z upon del x, q means del z upon del y, r means del square z upon del x square. Okay, s means del square z upon del x del y, or for any continuous differential function, this is also equals to del square z upon del y del z, del x. That is, the order doesn't matter. And t means del square z upon del y square. So these are the terms that you need to know, because throughout the PD we will be using. These are very standard notations that you need to follow. So let's start with the topic. Okay. So I'm going to start from reverse. That is, I want to discuss the elimination of arbitrary functions first. Okay. Elimination of arbitrary functions. Okay. So first is how to decide the order of the PDE, at how many times. Like in ODE, the number of constants that you had, the number of times you will differentiate. Okay, if the number of constant in ODE is 2, you will differentiate it 2 times. If the number of arbitrary constant is 3, you can differentiate up to 3 times. So that is followed here also. Okay, that is followed here also. That the number of arbitrary functions is equal to the order of the PDE. Number of arbitrary functions is equals to order of the PDE. So you should be knowing this. Okay. So, for example, let's say if I give you a simple thing, okay, a very simple question, but very, let's say if I give you a function phi x plus y plus z, comma, x square plus y square plus z square is equals to 0. What is equal to C? Here, and phi is arbitrary. Arbitrary. Phi can be any function. It can be sine, it can be cos, it can be log, it can be e to the power, like exponential function, or it can be any other complicated function. Okay, so phi is any arbitrary function. So now, what is the order of the PDE? Because there is only one arbitrary function. Therefore, order of PDE will mostly be 1. Order of PDE is 1. That is, you can have P, you can have Q, but you cannot have R, S, or T. This is not allowed. Okay, so how to do it? So here we use something we call the total differentials. Okay, total differential. We will use that concept. So let's say there is a function phi, which is a function of u and v, and which indeed u and v are both function of xy. Okay, xy. Then del by del x, you cannot find it directly. Okay, so if I want to find del phi by del x, it will always be equals to del phi by del u. That is, you go this way, del phi by del u, then you do del phi by del x into del u by del x. Okay, so you can del u cancel, del phi by del x, plus del phi by del v dot del v by del x. That is sum of this branch containing x and sum of this branch, that is sum of this branch containing x, right? Similarly, del phi by del y will be del phi by del u into del u by del x, sorry, del u by del y, because we're differentiating with respect to y now, del phi by del v dot del v by del y. So these are the two things that you have to keep in mind. In every question like this, implicit definition of a question, we do it in this similar manner. Okay, let's see the question and let's try to do it using this total differential. Okay, so you find x and y. Okay, you first add the branch containing x here, and you also add the branch containing x here. Similarly, for the second part, you will contain the branch containing y, and here also you will add the branch containing y. So this should be known to you. Okay, now let's see how to do the question. So the question was phi x plus y plus z into x square plus y square plus z square is equals to 0. Okay, is equals to 0. So you let u is equals to x plus y plus z and v is equals to x square plus y square plus z square. Okay, so del u by del x is equals to differentiation of x is 1, differentiation of y is 0 with respect to x, and del z by del x. Okay, del z by del x. This means 1 plus t. Similarly, del v by del x, this will be 2x, this will be 0, and this will be 2z into del z by del x. So you can take 2 common, okay, and you can write here x plus p z or zp. Okay, similarly, del u by del y is equals to 1 plus del z by del y is equals to 1 plus q, and del v by del y is equals to 2y plus 2z del z by del y. So again 2 common, y plus qz or zq, right? Now using total differential, okay, differentiate phi with respect to x, right? So there are phi u into v, phi u v is equals to 0. So if I differentiate it, so this will be del phi uv upon del x is equals to 0, right? And by total differential, we know that del phi by del x will be del phi upon del u into del u by del x plus del phi upon del v into del v by del x is equals to 0, right? From this, okay, write this as the first equation. Similarly, if I differentiate phi with respect to y, so del phi uv by del y is equals to 0, because the right hand side is a constant which will always give you 0. And by total differential, we know that the del phi by del y will be del phi by del u into del u by del y plus del phi by del v into del v by del y, right, is equals to 0. This is the second equation. Now all you need to do, we know the value of del u by del x, del v by del x, del u by del y, del v by del y. All we need to do is we have to eliminate these constant, these del phi by del u, del phi by del v, which can be easily eliminated. Let's see how. Okay, from equation 1, you can see that del phi by del u divided by del phi upon del v is equals to minus del v by del x upon del u upon del x, right? All I did is I took this part to the right hand side, and I took all the phi terms on left hand side and all the non-phi terms on the right hand side. So it will give you del phi by del u upon del phi by del v is equals to minus del v upon del x upon del u upon del x, which is equal to what was del v by del x. This will be minus 2 x plus pz upon this was 1 plus p, right? Similarly, from equation 2 also, del phi upon del u divided by del phi upon del v is equals to minus del v upon del y upon del u upon del y, right? Again the same thing, I took all the I took this part to the right hand side, and then all the phi terms to the left, all the non-phi terms to the right. So minus del v upon del y, so this was again minus 2 y plus qz upon 1 plus q. This is 4. Now see 3 and 4. These terms are equal, right? These terms are equal. It means if the left hand side is equal, the right hand side must also be equal. It means these terms should also be equal, right? So now just equate it. Okay. Now if I equate it, so minus 2 x plus pz upon 1 plus p is equals to minus 2 y plus qz upon 1 plus q, right? Now just cancel out minus 2 and multiply. So you will get qx plus x plus pqz is equals to py plus y plus pqz. pqz cancel. Okay, pqz cancel. Now this will give you qx minus py plus x minus y is equals to 0. And this is the required PDE. So now what is the process? The process is very simple. If you get an implicit function like phi, okay, like phi uv, this uv can be anything. This and this can be anything. Okay, it can be x cube plus y cube also. It can be x square y square plus 1 by z also. The thing is, It can be anything. Okay, it can be anything. All you need to do is you use the concept of total differential. Okay, and then you separate the terms containing phi upon u, del phi by del v, and you will get two same equations, right? Like here we got two similar terms, del phi by del u equal to del phi by del v, and you will always get this. You will always get this. Okay. For example, let's see one more question on this, and you will understand what I am saying. Okay, why you will always get this. Okay, so let's say if I give you some function h of x plus y plus z, x cube plus y cube plus z cube is equals to 5. Now here, if I take this ub, so del h by del x will be del h by del u into del u by del x plus del h by del v into del v by del x, right? Here also you will get this del h by del u, del h by del v, and when you divide with differentiate with respect to y, here also you will get del h by del u into del u by del y plus del h by del v into del v by del y. Here also you get the same terms, and this both are 0. So from there you can separate these terms and you can compare these del u by del x, del v by del x with each other, and you will always find the equation. This is the very standard way. These are very simple questions, and if you see, these are one of the most frequent 10 markers asked in PDE, in 10 markers, the formation of PDE. That's why I wanted to discuss this. Now, as a homework, you guys can try one question. You guys can try one question, which is okay. You guys can find question. Phi of x square plus y square plus z square, comma x cube plus y cube plus z cube is equals to 5. Okay, this is the find the PDE. Find equation and order of PDE. This is the very simple question. Now, this was a type 1 question where the implicit function was given. Okay, now come to type 2. Type 1 was implicit function was given, phi of uv, z, anything can be given. There can be 3 variables also. Usually they ask for 2 variables. Now, type 2 is when function is not implicit. Let's say, if I say z is equals to f of x square plus y square. Now this is explicit function. Z is given explicitly as a function of x square plus y square. How to go about it? Now, number of arbitrary function is 1. So this implies order must be 1, right? Order must be 1. That is, you can only differentiate it one time in the sense, one time with respect to x and one time with respect to y. Okay, but you cannot go in higher differentials. That is, you cannot go for peak like RST. Okay, so that cannot happen. So let's see how to go about it. Okay, so if I differentiate with respect to x, so you will get del z by del x, which is equals to p, is equals to f dash of x square plus y square, then the differentiation of x square plus y square with respect to x, which is 2x, right? Similarly, if I differentiate with respect to y, del z by del y is equals to q, is equals to again fz x square plus y square into differential of x square plus y square with respect to y, which is equal to 2y. Okay, if you see from these equations, something is common. This term is common. So from this we can get f dash x square plus y square is equals to p by 2x is equals to q by 2y. And now we using these we can find our equation, right? All function has been eliminated from this. py minus qx is equals to 0. This is the desired equation. Very, very easy question. Okay. Now let's see if what if there are two functions. Okay. Now let's say question is z is equals to function of x square minus y plus function of plus some other function g of x square plus y. Here total there are two functions, so the order can be up to 2. Okay, that you can have RST. So let's differentiate this with respect to x. So p is equals to 2x into f dash x square minus y plus 2x g dash x square plus y, and q is equals to minus 1 f dash x square minus y plus g dash x square plus y. Right? This is the first after differentiating only once. After differentiating only once. Now, if I differentiate it again, then r is equals to, okay, r is equals to, here you will product rule will apply. So 2x ka differential is 2 f dash x square minus y plus 2x f double dash x square minus y into 2x, right? Similarly, 2 g dash x square plus y plus 2x into g double dash x square plus y into 2x, right? So if you simplify it, you can write it as 4 of x square into f double dash x square minus y plus g double dash x square plus y plus 2 f dash x square minus y plus g dash x square plus y. Okay. This is the first thing you need to know. Then if I differentiate with respect to y, so t will be is equals to, okay, t will be is equals to, if I differentiate it again with respect to y, so minus minus plus f double dash x square minus y, and from here g double dash x square plus y. So from this you got 4 equation, right? The equation number 1, 2, 3 and 4. If you see, this term is t itself, right? This term is t itself. So, and if you see this term, okay, if you see this term may p by 2x. See this, because if you take 2x common, p by 2x. So just put these values. So from here, r is equals to 4x square into t plus 2 into p by 2x, right? So if you simplify it again, so 4x cube t plus p is equals to rx, and this is the differential equation for this question. So the thing was very simple. You have to differentiate as many times as the number of functions are there. If there's only one function, you can go up to the level of p and q. That is, you can differentiate once with respect to y, once with respect to q. Okay. If there are 2 functions, you can differentiate to the level of second degree. So you will get 3 more equation RST. Just see how many equation you want. So you at max there will be 5 equations, and using this equation Okay, little observation, you can eliminate the functions and you can find the question. You can find the equation, clear equation. So this is not very tough. This can be done. Mostly question, if you see, are asked from the implicit functions. If you see the PYQ, mostly questions asked are from type 1. Like these type of questions have been asked. Okay. Now come to the second part, that is elimination of arbitrary constants. Okay. Elimination of arbitrary constants. Okay. The first thing is equation will usually be in your 3 variables. So if number of constants is equals to number of independent variables, then PDE has order 1. That is, you will have only P and Q. Okay, not RST. And if number of constant exceed the number of, that is a number of constant greater than number of independent variables, then PD will have order greater than 1. Okay, that is, you can go up to RST. Okay. So this is the general rule, but this is not always follows. Like there is one question in the book where there's only one constant, but still you differentiate it twice. That is, you go to the level of RST. Okay, so this is not a very strict rule. In 19, so in all questions that you get, you will do this. There's only one special question in the book. In that question, you can go. You are allowed to go to level 2. Okay, just mark that question. So if by chance it comes in exam, you know, you don't waste time just fiddling around it to make it a linear PDE. Okay, so let's see some questions, easy questions first, and then I will tell you what kind of question are actually asked from this. Okay, so let's say if I give you Z. So first understand what is the dependent and independent. Okay, let's say Z is equals to function of XY. So now here X and Y can take any value. They are independent. And Z is dependent on the values of X and Y. This is dependent. Okay. Let's say there is a function of W is equals to G of XYZ. Here XYZ all are independent. It is 3 independent variables. Okay. And W is dependent. Okay. Usually you will get a 3 variable equation where Z will be dependent, X and Y will be independent. Okay. X and Y will be independent. So let's see. Let's say if I give you a question, Z is equals to A times X plus Y plus B. Here number of independent variables are 2, X and Y, and numbers of constants also equal to 2. Constants, arbitrary constants equal to 2. Independent variables is equals to 2. So therefore, order of PDE must be 1, right? So let's differentiate with respect to X. So del Z by del X, which is called P, is equals to A. And if I differentiate with respect to Y, del Z by del Y is equals to Q, also A. From this, I can say P is equals to Q is the differential equation, is PD. One of the most easiest question. But this kind of question are not like, they usually don't come in the exam. Usually they never come in exam. These simple questions will never come in exam. Mostly the kind of question that you will get in the exam, okay, are from geometry point of view. That is, you will not be given equation directly, you will first have to form the equation, and then you have to eliminate the constant, and then have to find the PDE. Okay, like for example, question that will come in the exam and has come in exam in a UPSC exam is, okay, the question is form partial differential equation of spheres having center in XY plane and radius 5, or let's say radius k, any constant k. This is not arbitrary constant, this is the fixed constant. Okay, fixed constant. Okay, what will the, so as the center lies in the xy plane, so the center z coordinate will be 0 and the radius is k. So first you have to think what is the equation of sphere. So here equation of sphere from the knowledge of 3D. That's why the knowledge of 3D will be required in PDE a lot. For formation of PDE, lot of question will require knowledge of 3D. Okay, knowledge of how to write equation of tangent plane, how to write equation of cone, all this knowledge will be required. Okay, what is the equation of sphere? So x minus alpha square plus y minus beta square plus z minus gamma square is equals to k square. But because the sphere lies in the xy plane, so the z coordinate of the center will be 0. The equation of sphere will reduce to x minus alpha square plus y minus beta square plus z square is equals to k square, where alpha and beta are arbitrary constants. Okay, alpha beta are arbitrary constants, right? Alpha beta are arbitrary constants. So in this alpha beta, the number of independent variables are x and y, 2, constants are 2. It means the equation will be linear. So how to do it now? Now once you form the equation, everything is easy. Differentiate with respect to y and with respect to x. Okay, so with respect to x, the differential will be 2 x minus alpha. This will be 0 because y term will be 0, plus 2z into del z by del x is equals to 0. From this you can see p is equals to x minus alpha, okay, minus x minus alpha upon z. And when you differentiate with respect to y, similarly you will get q by symmetry, you can guess, is equals to y minus beta upon z. Okay, y minus beta upon z. Or you can also say this, that x minus alpha is equals to minus pz, y minus beta is equals to minus qz. Okay, now if I put this in the original equation was x minus alpha square by minus beta square plus z square equal to k square. So you will get minus pz square plus minus qz square plus z square is equals to k square, right? Z square is equals to k square. From this, z square 1 plus p square plus q square is equals to k square. Why? This is the differential equation, required differential equation. Okay, this is the required PDE. In the order is 1, the degree is not 1 because this is square terms. The order is 1. PDE of order 1. This came in UPSC in 1999. Okay. So why did we not eliminate k? Because k is not an arbitrary constant, it's a fixed constant. Okay, fixed constant. Now, what kind of question actually come in the exam? Okay, so let's see some questions that came recently. Okay, so in UPSC 2018, okay, in 2018, the question came was, find PD of tangent planes of ellipsoid x square let me check the question. Values don't matter anyway. So x square by 4 plus y square plus z square equals to 1, which are not perpendicular to xy plane. Okay, this line was very important. Not perpendicular to xy plane. So first thing is you need the knowledge of conicoids. Okay, so knowledge of conicoid. What the knowledge is required? How to write the equation of tangent planes. Okay, so any equation of tangent plane of any conicoid ax square plus by square plus cz square equal to 1. Okay, this has tangent plane lx plus my plus nz is equals to plus minus under root, okay, l square by a m square by b plus n square by c. Okay, so this much knowledge is required, which you study in 3D. So from this, I can write the equation of tangent planes of this. What will be the equation? From this, Lx plus my plus nz is equals to, okay, is equals to plus minus, okay, here a is 1 by 4, okay, 1 by a will be 4, so 4l square plus m square plus n square, right? This is the thing. This is the equation of tangent planes. Equation of tangent plane. Now it has given one more condition. Why? Because if you see, there are two independent variables x and y, but there are three constant l, m, n. So it can go to higher order, but it cannot go to higher order because one more condition is given, that it is not perpendicular to plane. Okay, not perpendicular to xy plane. So if it were perpendicular to xy plane, that it will be parallel to z-axis. That is, then the angle between normal and z-axis will be 90 degree. So let's say if it were perpendicular to plane, then what will happen? L, M, N dot 0, 0, 1 must be 0. That is, from this n equals to 0. Because it is not perpendicular, this implies n cannot be 0. This is very important. Okay, this is very important. Because n cannot be 0. Because it is not perpendicular to xy plane, so n is not 0 at any cost. Okay, because it is not parallel to the axis. So n cannot be 0. Because n cannot be 0, you can divide the whole equation by n. So you will get L by nx plus m by ny plus z is equals to plus minus under root 4 L by n square plus m by n square plus 1. Now if you see, if I take L by n as some constant a and m by n by some constant b, ax plus by plus z is equal to plus minus under root 4a square plus b square plus 1. They are now only two constants. They are now only two constants and two independent variables. So the order will be 1 only. This is the 2018 question. So you will find, actually in the exam, you will get geometrical questions. Okay, you will get equation. You will have to write equation of sphere, equation of cone, sphere of tangent plane, equation of tangent planes. All this you have to think. The formation part is difficult. Now, reduction part is easy. Now you can easily reduce it. Now differentiate with respect to x. Okay. With respect to x, we get a plus p is equals to 0. This gives p is equals to minus a. Okay. Similarly, if I with respect to y, when you differentiate, you will get b plus q is equals to 0 because right hand side is constant. So this will give you q is equals to minus b. Now just put the values, you will get your equation. Okay, so you will get, okay, minus px minus qy plus z is equals to plus minus under root 4 p square plus q square plus 1. Okay, if you want to square, you can square it. If you don't want to square, even that is good. So you can write it as px plus qy. You can write z is equals to px qy plus minus under root 4p square plus q square plus 1. So this will be the equation of the tangent plane to the given ellipsoid, which is not perpendicular to xy plane. So the direction part was very easy, one step, but the difficulty was in the formation part, thinking all this. First you need to know how to write equation, then you need to think, okay, n is not equal to 0, I can divide it. That was there, so that can be done. Okay, one other thing will be that sometimes another thing will not be given, but you should know the relation that if lm and are direction cosines, this means L square plus M square plus N square equals to 1. So this thing can always be used. Okay. Let's see one question, okay, which is very, very important from the exam point of view, that you have to remember, because there's a particular way to solve it. Okay, the question is, find PDE of cones with vertex at origin. Find PDE of cones with vertex at origin. This is the most important question. Okay, most important question that you need to know at any cost. At any cost, you need to know the question. Okay, so first is lessons from 3D chapter. What is the lesson 3? So any homogeneous equation of second degree represents a cone. This you must have studied in your 3D. So equation of cone with vertex at origin is actually given by ax square plus by square plus cz square plus 2f. Here also you need to make it homogeneous. So 2f yz, that is x is missing, 2g, okay, xz, that is y must be missing, and 2h xy, that is z will be missing, equal to 0. So this is the equation. Now what we do is, this is the equation. Now differentiate with respect to x. So you will get 2ax plus 2cz into del z by del x, that is p, plus 2fy del z by del x, p, plus 2g, here product rule will apply, right? 2g z plus 2gx del z by del x, which is equal to p, plus 2hy is equals to 0. So if I take 2 common, okay, and then I club the parts containing p and club the parts containing not containing p. So ax, then gz plus hy plus p times, you will have cz plus fy plus gx, right? This is equal to 0. This is your equation 1. Similarly, differentiate with respect to y. Differentiate with respect to y. You will get 2by plus 2cz del z by del y, which is q, plus here product rule will apply, right? So 2fz plus 2fy into q plus 2g, here you will have xz. X is constant for if you differentiate with respect to y, so x will be treated as constant, 2 into q. Now you have 2hxy. So y will become 1. 2hx is equals to 0. Now you can take 2 common, okay, and it will become 0. Now clubbing the terms containing q and not containing q. So here you will have by plus fz plus hx plus terms containing q. Here you will have cz plus fy plus gx is equals to 0. This is the second equation. Now the thing is, there is a little manipulation that you have to do. Okay, so you will multiply 1 by x, 2 by y, and add. Okay, and add. So you will see, you will get ax square plus gxz plus hxy, okay, plus by square plus f, okay, fyz, f of yz plus h of, okay, xy plus px plus qy into cz plus fy plus gx is equals to 0. This is the equation, third equation that you will get. Now see this beautifully. Ax square plus bx, let me simplify it for you. This will be ax square plus by square plus 2hxy plus gxy plus fyz, okay, plus px plus qy times cz plus fy plus gx is equals to 0. Now again you have to do some more manipulation. See, ax plus this term, okay. Now equation of cone was ax square plus by square plus 2fyz plus 2gxz plus 2hxy equals to 0. So from here you can see ax square plus b square plus 2hxy is equals to minus 2fyz minus 2gxz. Now you put this value, you put this value in this equation, okay, and simplify. So you will get minus 2fyz minus 2gxz plus gxz plus fyz, okay, this is z, gxz, okay, plus px plus qy into cz plus fy plus gx, okay. Oh sorry, here you will have your this term also plus cz square. So here you will have minus cz square also. Here minus cz square will also come, okay, minus cz square will also come. So here you will get minus cz square minus gxz minus fyz plus px plus qy into cz plus fy plus gx is equals to 0. Now we are very close to the answer. See these terms, very similar terms, okay. So if you see, you can write it as px plus qy into cz plus fy plus gx minus z common cz plus gx plus fy equals to 0. From this, px plus qy minus z into cz plus fy plus 3x is equals to 0. This term cannot always be 0, right? Because the equation of cone. So for there will be many different cones. So if this is always 0, it could lead to a problem. You are restricting the cone. Okay, and anyway, it will give you a singular solution. So you take this part equal to 0, px plus qy is equals to z. And this is the equation of cone with vertex at origin. With vertex at origin. Okay. This is the question that comes. This is the question that comes. Now, there was another question that I already solved on YouTube, or you can check it. The question was, find. So please go through this question again. This is a lengthy question, but this is a very tricky question. So you have to solve it 1-2 times yourself to understand how to go about it, what manipulation to do, what not to do. Because if it comes in exam, it can come. Okay, these kind of questions are very repetitive. Okay, now let's see the question that came in very many years ago, like 10-20 years ago. The question one, find PDE of cones with vertex at 2, 3, 4. Okay. Now the problem here is through our syllabus of 3D, we actually know how to write equation of a cone with vertex at origin. But we don't really know the equation of cone with vertex to a given point, 2, 3, 4, 5, 7, 6. So here you can do a small manipulation. What is the manipulation? I know that I can shift the origin. Okay, that you must have done in 11, 12 for IDG preparation. Shift of origin to 2, 3, 4. That is, if this is the real origin, I will shift it to some point 2, 3, 4, and everything will change, right? So if in the new coordinate system, let's say if 0, 0, 0 is the origin and there is a point x, y, z. So if we shift the origin to 2, 3, 4, this will be capital X, okay, capital Y, capital Z. What will be the relation between these two? If you see, okay, what will be the relation between these two? So capital X is equals to X plus 2, capital Y is equals to small y plus 3, and capital Z is equals to Z plus 4. These are the relation. Okay. These are the relation. Okay, sorry. It is the other way around. Okay, the relation is not this actually, because you are shifting origin to 2, 3, 4, not 2, 3, 4 to origin. So small x will be capital X plus 2, small y will be capital Y, okay, plus 3, and small z will be capital Z plus 4. Okay. So this is the thing. You have to do it like this. So now I know this. Now I know. Now in the new coordinate system, in new coordinate system, okay, origin is 2, 3, 4, right? So equation of cone at 2, 3, 4, that is equation of cone at origin, we just solved, will be P capital X, okay, Q capital Y equal to capital Z. I didn't change the PQ because the reason is del, okay, del Z by del X is equal to del Z by del capital X, because constant doesn't change the differentials, that we know, right? This is the reason capital, I didn't write capital P. You can write capital P and you can also say capital P equal to small p. Now what is capital X? Capital X is equals to x minus 2. So P of x minus 2 plus Q of y minus 3 is equals to small z minus 4, right? This will be the equation. This is a very simple way to do it. Okay, one more way is there to do it, that you can see the question PYQ section on YouTube. Okay, that can be done. Now let's see one more question. So what we learned till now is elimination of functions. Mostly implicit function is asked. There's a set way to do it. Very easy question. Other question can also be asked. There are multiple, like where you have to eliminate 2 functions, 3 functions. There you will have to do some calculations. Okay, and it will depend from question to question. There's no set way to do it. You have to see what are the common parts and you have to eliminate it accordingly. You have to eliminate the functions anyhow. Okay, but in elimination of constant, arbitrary constants, usually direct questions are not asked in UPSC. They will give you some geometrical questions and you have to form the equation yourself and solve the equation yourself, like we just solved for the set of all the cones with vertex origin. Like similarly, there was one question which is also given in MDR, question of PDE of right circular cone with vertex on z-axis. Okay, vertex on z-axis. So here also you need knowledge from 3D geometry. You need knowledge from 3D geometry, right? What is that knowledge? That what is the equation of right circular cone? X square plus y square is equals to z minus c, okay, square, and some constant angle. Okay, some constant angle, 10 square alpha. Okay, or you can write it like this also. X square plus y square is equals to z minus c square into some constant k. So this is the equation. And now you have to eliminate c. That's all. Right? You have to eliminate c because alpha is a constant. This is a constant. This is not an arbitrary constant. This is a fixed constant. Otherwise, the cone will not be a right circular cone. Right circular cone means it has a fixed angle. Okay, fixed constant. You have to eliminate you have just one arbitrary constant. So obviously, the equation will be linear, and you can easily do it. You can find equation relation between P and Q. Let's see. If I solve it, so 2x is equals to 2z minus c. Okay, 2k into z minus c into P, and 2y is equals to 2k into z minus c into Q. From here you can see, okay, x by P equal to y by Q. Okay, like if you see, if these terms are common, if I divide the two equations only, you will get x by y is equals to p by q. From here, qx minus py equal to 0 is the equation. It's a very easy question. Question was very easy, but if you don't know how to write the equation of right circular cone, you can never do it. Right? No, a lot of knowledge from 3D will be required for solving these questions. Okay, will be required for solving this question. Like for example, find partial differential equation of planes. Okay, find the partial differential equation of all the planes which are at constant distance k from origin. So again, knowledge from 3D, equation of any plane my plus nz is equals to a, where l, m, n are actual direction cosines. Okay, that is l square, m square, n square equal to 1. Right? You can like it like this, or you can also ax plus not. Let's take something else. Okay. Okay. Let's take. Cx plus dy plus df is equals to a upon under root c square plus d square plus e square. You can write it like this also if you are taking these direction ratios. Better to take it this. This is more simpler form. Then if you take this, There will be a little more calculation, but you can still do the questions. So this is the question. So it is saying it is constant distance A. So Lx plus My plus Nz is equals to A, and also L square plus M square plus N square is equals to 1. These are the equation that we have to use. Now differentiate with respect to X, you will get L plus NP is equals to 0, right? So L is equals to minus NP. Similarly, if I differentiate with respect to Y, M plus NQ is equals to 0. This gives M is equals to minus NQ, right? Now put it in the equation. From there, minus NP square plus minus NQ square plus N square is equals to 1. From this, you can see that N square is equals to 1 upon P square plus Q square plus 1, right? So from this, N is equals to plus minus 1 by under root P square plus Q square plus 1. Now what was L? L was NP. So L will come out to be minus, okay, minus plus, okay, sorry, minus NP. So it will be minus plus P upon under root, same thing, and M will be minus plus Q upon under root, same thing. Now everything is found, element is there. So if I write it like this, so it will be minus P upon under root P square plus Q square plus 1 X minus QY upon under root P square plus Q square plus 1, okay, plus N will be here plus Z upon P square plus Q square plus 1 is equals to A. I just put the value of element. Now from this, Z is equals to Px plus Qy, okay, Px plus Qy plus A times P square plus Q square plus 1. This is the required equation of the plane. Now other variation can be given. Find the equation of planes such that the sum of its intercept is equal to K, where like, so if I write it like this, so equation of plane will be X by A plus Y by B plus Z by C equal to 1, where A plus B plus C is equals to K. From here you can find C, K is equals to K minus A minus B equal to C. Put it there and then you will solve, because you need to give it a linear factor mostly. So these kind of questions are asked again and again. Okay. So please solve these questions. See the kind of PYQs that has been asked. Okay, a lot of question has been asked from this. So mostly question will come from either geometrical, if to eliminate constants, so you have to use a lot of geometry. You will need a little knowledge of 3D, not little. You need to know the basic, how to write the basic equations. So that will be required. And then other type of question that are very frequently asked is implicit functions. That is very easy to solve, very easy to solve. Just solve it. So go through the questions, go through PYQs again. You can find the PYQs on our website. We have a website called www.g20maths.com. Here, when you open the website, you go to the resource page. Okay. Resources. In resources, you will find topic wise PYQs. In topic wise PYQs, let's say if you open PDE, you can find, let me show you. Okay. Let me show you. So let's go to your browser. Okay, you go to your browser and you type www.g20maths.com. okay, on your phone or on your laptop, you go there, you go to the resources page. Okay, and this is on the top. You can see maths optional chapter wise PYQs. You can go to paper 1, paper 2, go to paper 2, click PDE, drive will be opened. And in the drive, you can see the first is formation of PDE. In formation of PDE also, you have in last 10 years, 10, 11 years, you have the kind of question that has been asked. You can see all the questions are mostly geometry, using geometry, elimination of arbitrary constants. For elimination of function, you will see, you can get a function like this, okay? Or you can get a function like this, the implicit one. Lot of implicit one. Here again, an implicit one. Here again, implicit one. Lot of question on implicit functions are asked. So 10 markers usually come from this part. So you should know this. So this is the end of the session. I will take another session on Chapet and Lagrange soon. So best of luck. Study hard.